Hi everyone, it's Shiv Bhushati with Shiv's Solution. This is the video by the troubleshooter of your mass phobia. If you feel it's worth of watching, please hit like and subscribe to our channel. Well, dear students, let's start this video with product of vectors. Dear all, we know that if you do the product of any two numbers, so we get numbers, no doubt. If you do the product of any two matrix, we get matrix. But this is somewhat different. Okay, so then how it is different compared to that? This here the difference is, if you do the product of vectors, it is not necessary that you have to get vectors only. So there are two possibilities. So when you do the product of vectors, there are two possibilities. So what are those two possibilities? Let us check it out. So when you do the product of two vectors, as already I said, it results in two ways. The one is scalar product. In that one, we call it as a scalar product, or you can also call it as a dot product. And the under one, we call it as a vector product. You can also call it as a cross product. Okay, dear students, let's get it done here. Why we call it as a scalar product or dot product? Why we call it as a vector product and cross product? And what difference is there between these both? So let us start with the scalar product. Very simple. I'll make it clear. So let me take two vectors. Vector A and vector B. So I have taken here two vectors, vector A and vector B, with inclined some angle theta. Okay, here vector A and vector B are non-zero vectors, means theta has some magnitude. Okay, so then the scalar product of vector A and vector B, we are discussing on scalar product. Okay, so then the scalar product of vector A and vector B will be denoted like this: vector A dot vector B. The scalar product of vector A and vector B will be denoted like vector A dot vector B, and that will be defined as magnitude of vector A into magnitude of vector B into cos theta. I mean, so vector A dot vector B is equal to, we get magnitude of vector A into magnitude of vector B into cos theta. There is no any derivation for this, dear students. Just you need to remember this formula. So vector A dot vector B is equal to magnitude of A into magnitude of B into cos theta. Now the question is, why we call it as a scalar product or why we call it as a dot product? Simple. See, dear students, I hope you know the magnitude of A is nothing but we get one scalar quantity. I mean, it has scalar. It's a number, constant number we get, correct? If you do the magnitude of any vector, we will get one number. Means maybe 5, 6, 7, 8. Similarly, magnitude of B means also we will be getting one number. It is also one scalar quantity. Okay, and similarly, cos of any angle you take, cos 0, 1, cos 90, 0, cos 45, 1 by 2. So these are also again number only you will be getting. That means this is also one number. I mean, this is also a scalar. This is also a scalar. This is also a scalar. Means all three will be getting number. So if you multiply these all three numbers, we'll be getting output as a again result number only. We'll be getting the result number only. When you do the product of these three scalar, we get the result as again scalar only. So that is the reason we call it as a scalar product. Since these three are scalar quantity, and these both will be denoted by this way, dot. These both product will be denoted by with the dot. That's the reason we call it as a dot product. Since we use the dot symbol to multiply that or to product that, we are taking the help of dot, so we call it as a dot product. That's the reason we call it as a dot product. This is the reason we call it a scalar as well as dot product. So why we call vector product, that we got in the later, that we move to the later. Okay, let us study now here. Some important points are there with respect to the scalar product. There are some important points are there with respect to the scalar product. So which are those? So the first one is, suppose if vector A and vector B, or suppose vector A or vector B, any one of that vector is 0. Imagine any one vector, either A or B, any one vector is 0. Then what will be the product of scalar product of that two vectors? No doubt, scalar product of that two vectors will be 0. If any one vector is equal to 0, then its dot product will be equal to 0. Dot product will be equal to 0. Okay, because magnitude of A, either magnitude of A is equal to 0 or magnitude of B is equal to 0. In these two, any one is 0 means, in these two, any one is 0 means, so the magnitude of that will be equal to 0. And then if you do use that formula, we will be getting output 0. So here is one small question to you people. I need that answer from you only. I'm expecting answer from you only. Okay, here vector A also is not equal to 0. Imagine vector B is also not equal to 0. This is also imagine. It's one of the important point and important question which that ask for the 2 marks. Yes, it's repeated many times. Suppose, imagine that vector A is also not equal to 0, vector B also not equal to 0. Then is there any possibility of getting A dot B is equal to 0? Is there any possibility of getting A dot B is equal to 0? Please think over this. Remember, recall that formula. What is the A dot B? What is A dot B formula? So what's A dot B? Magnitude of A into magnitude of B into cos theta. Here this is also not equal to 0, this is also not equal to 0. If any one of these equal to 0 means, then A dot B is equal to 0, we got. Okay. Now my question is, here both that vectors are not equal to 0. Then is there any possibility of getting A dot B is equal to 0? Vector A dot vector B is equal to 0. My answer is yes. My answer is yes. How, sir? Simple. Just go through this one. Here, vector A and vector B are non-zero vectors. Both are non-zero vectors. But theta is equal to pi by 2. I mean, angle between that both the vectors. Angle between, imagine, it is vector A and it is vector B. Okay, the angle between that both is 90 degree. Angle between that both vector is 90 degree. Then what will be your A dot B? Dot product of that both vectors is magnitude of A into magnitude of B into cos 90. So cos 90 is nothing but, already we know it is 0. So since it is 0, if you multiply any number with this 0, we will be getting output 0. Therefore, even though if vector A or vector B is not equal to 0 also, we get A dot B is equal to 0 when the vector A and vector B are equal to, are perpendicular to each other. When vector A and vector B are perpendicular to each other, then also we get dot product is equal to 0. Then also we get dot product is equal to 0. It's an important point which they ask for the 2 marks. So please keep in your mind that point. So now let's move to the next point. So what's the next point? The next point is, if theta is equal to 0, means the angle between vector A, there is vector A, and vector B is also coincide with vector A. I mean, angle is 0. If angle is 0 means, then what will be your dot product? Our dot product will be equal to 1. Our dot product will be equal to 1. Because here, when the angle is 0, we get cos 0. We get cos 0. So, since it's a cos 0 value is what? Cos 0 value is 1. Therefore, we get A dot B. Vector A dot vector B is equal to magnitude of A into magnitude of B. Vector A dot vector B is equal to magnitude of A into magnitude of B, because cos 0 is 1. We get this part as a 1. Okay, we get this part as a 1. So we get vector A dot vector B is equal to magnitude of A into magnitude of B. There is some particular condition. What's that particular condition? Then what will be the vector A dot vector A? Vector A dot vector A. So vector A dot vector A will be, we get square of its magnitude. So please keep in your mind, vector A dot, this point I'm going to use again in this video only. Okay, so vector A dot vector A is equal to square of its magnitude, because here theta will be again 0 only. So suppose the next point is, suppose the theta is pi, I mean 180 degree. Then what we get? So we know cos 180, cos pi is equal to what? Minus 1. Therefore, vector A dot vector B is equal to magnitude of A into magnitude of B into cos theta. Cos theta is minus 1. That's nothing but minus. So vector A dot B is equal to, we get magnitude of A into magnitude of B. Negative of magnitude of A into magnitude of B. Since cos 0 is equal to 1, so we get positive of magnitude of A into magnitude of B. But here we get negative. Okay. So the next point is, so please listen carefully this one. If you compare with respect to observation 2 and 3, just note these 2 points. With respect to these 2 points, I'm taking your new points, I'm making it as a new concept. What is that? So since we know IJKR what? unit vectors. I cap, j cap and k cap are unit vectors. Then what will be your I dot I? We know a dot a is equal to what? Magnitude of a square. So a dot a is equal to magnitude of a square. Third point we have discussed, correct? So magnitude of a square. Then I dot I is equal to magnitude of I square. Magnitude of I. We know the magnitude of I is 1. So 1 square. 1 square is nothing but 1. That means I get I dot I is equal to 1. Similarly, j dot j is equal to 1. And k dot k also will be equal to 1. Then what will be the I dot j? I dot j. See, this is your I, this is your j, this is your k, correct? So that means between I and angle. So I and k are inclined with angle 90 degree. I and k or I and j also inclined with an angle 90 degree. That means if you do the dot product of I and j, so cos 90 is 0. So we get I dot j is equal to j dot k, or you can take k dot I, both will be equal to always 0. So please note on this point, I dot I, j dot j. So again I'm telling, please dear students, note on this point, I dot I, j dot j, k dot k is equal to 1. How we get it 1? Already I have discussed here, this point, okay? And I dot j, j dot k and k dot I also will be equal to 0, because the reason is what I discussed here, between that ij or jk or ki will be 90 degree, angle inclined between that will be 90 degree. That's the reason this will be equal to 0. So now let's move to the next point. If they ask you find the angle between, they will be giving you two vectors, vector a and vector b. They will be giving you vector a and vector b. Then what is the angle between that both that vectors? They ask you find the angle between vector a and vector b. So we know that vector a dot vector b is equal to magnitude of a into magnitude of b into cos theta. But they are asking us to find out cos theta. Keep cos theta there itself. So then vector a dot vector b. So when you take magnitude of a into magnitude of b to the left side, it goes to the denominator place. So remains here first. That means cos theta is equal to vector a dot vector b divided by magnitude of vector a into magnitude of vector b. Or you can also write it as theta is equal to just cos, I'm taking this side, cos inverse of theta is equal to cos inverse of magnitude of vector a dot vector b divided by magnitude of a into magnitude of b. So the next last one, this is one property. You can say it's property, that commutative property. What is that commutative property? Vector a dot b will be always equal to vector b dot vector a. These two, see, just give it as the numbers only. Vector a dot vector b will be always equal to vector b dot vector a. Anyway, both are scalars only. How we get means simple. Vector a dot b is equal to magnitude of a into magnitude of b, correct? Into cos theta. Vector b dot vector a is equal to magnitude of b into magnitude of a into cos theta. Since these both are same, will not get changed. So we have to check it out, these two only. See, vector a dot, magnitude of a into magnitude of b is on scalar, multiplication of two numbers, 3 into 2, imagine. Here it will be 2 into 3. If it is 3 into 2, then it will become 2 into 3. Is there any difference? 3 into 2, 6. 2 into 3, 6. 3 into 2, 2 into 3, 6 only. So we can say that vector a dot vector b is equal to vector b dot vector a. So this satisfies the commutative property. Let's move to the some other properties. We study the some other property. What are the properties? The first property is like this: distributive property of scalar product or addition. We are discussing this over addition. So what is that? Let vector a, vector b and vector c be the any three vectors. Then vector a dot vector b plus vector c is equal to vector a dot b plus vector a dot c. This is our distributive property. Okay. The next property is, let vector a and vector b be the any two vectors, and lambda be any scalar. Lambda is one number, normal number. Okay. Then this is a property, please keep in your mind. Lambda into vector a dot vector b is equal to lambda into vector a dot vector b is equal to vector a into lambda in dot vector b. These all will be always equal to each other. Here now the point is important. Since here vector a and vector b are normal vectors from the argument. Suppose if it is in the vector form means it's in terms of ijk. Vector forms, vector A and vector B, if they given the component form, if they given the component form. If they given vector A and vector B in the component form, I means vector A they will give A1i, A2j, A3k in terms of ijk, okay, and vector B they will give B1i, B2j, B3k. So both are in the component form. Then what will be the A dot B? Then what will be the vector A dot B? So simple. Here just I am writing here. Then the scalar product of when vector A and vector B are in the component form, then the vector A dot vector B is equal to vector A dot vector B. This is full vector B, this is full vector A. Okay, and the next we get, just see here simple, just multiply A1 into B1 I into I plus A1 into B2, sorry, A1 into B1 I dot I plus A1 into B2 I dot J plus A1 into B3 I dot K. This is over. Now move to second one. A2 into B1 Ji, A2 into B2 Jj, A2 into B3 Jk, A3 into B1 Ki, A3 into B2 Kj, A3 into B3 Kk. So we get this one. We get this one. Just write it as a equation 1. Just write it as a equation 1. And here, dear students, we are using the, as already we discussed in the note, some important points you need to be note. I said the last slide, correct? So which are they? I dot I, we know that I dot I dot I, J dot J, and K dot K all will be equal to always 1. I dot J, J dot K or K dot I will be equal to 0. Correct? So that means, now see here, this is I dot I means nothing but 1. So we will be getting A1, B1 will be as it is, will be continue here. And I dot J, that means this term will become 0. I dot K, this is 0. J dot I will become 0. And the J dot K becomes 0. K dot I will become 0. K dot J will become 0. And K dot K. So here left out element is this one, this one, this one. That means the left out will be, when you do the vector A dot vector B dot product of two vectors when it is in the component form. When it is in the component form, we get A1 B1, see this one, A1 B1 plus A2 B2 plus A3 B3, A3 B3. This is a formula which you need to remember, which may ask for 2 marks. Theorem they will not ask, there will be some problem based on this concept only. Okay, now let's move to the very important point, that is projection of a given vector on a particular line. We will ask here projection of a vector, projection of a vector on a particular line. Again I am telling it's important, which they may ask for 2 or 3 marks. So now see here, I hope you can see here, just imagine this is a line L, AB is a line L. Okay, now here is a vector A, or you can call it as a PQ, or you can call it as a PQ, vector PQ, or I can call it as vector A. I want to know the projection of vector A, projection of vector A or PQ on line L, So what is the projection of PQ on line L? They will ask question, projection of PQ on line L or projection of vector A on vector B, whatever it is. So to know that one, I want to know the projection of PQ on line L. Simple, dear students. Projection of PQ on line L is nothing but the impact of PQ. The impact of PQ on line L. So very simple. The impact of PQ on line L is AB. The impact of PQ on line L is AB. This is only called the projection. The impact of PQ on line L is AB. So here just for this, that vector A be a given line, A and B be the 2 points, foot of the points, which is drawn or fall perpendicular from point P and Q. Okay, so just note this point, A and B be the foot of the perpendiculars which fall from P and Q on the line L, Okay, then AB only is called, as I said, we are now going to find out here projection, correct? Projection of a one line on particular line. Okay, or projection of a vector on particular line. So then AB is called the projection of vector A or PQ. Projection of vector A or vector PQ on line L is AB. Now I need to find out what is AB. So now I came to know the projection of or projector of vector A on line L is AB. Okay, then what is the value of AB? That I need to find out. Okay, let us find out what is the value of AB. So to find out that one, just make a note here, please. Draw PM. This is a PM perpendicular to QB. Perpendicular to QB. Okay, then what we get when you draw PM perpendicular to QB, automatically this PM will become AB, correct? PM will become AB. So then take here angle theta. Theta is the angle between PQ and PM. It is nothing but theta is the angle between PQ and AB because AB and PM are same, correct? So now let me take here theta is the angle between vector A and AB or line L. Line L. Okay, then in triangle QPM, just apply the cos for take the cos here, cos t ratio please use, that is cos theta. Cos theta is equal to what we get here, cos of theta is equal to adjacent. What's the adjacent? PM divided by hypotenuse. What's the hypotenuse? PQ. Okay, so now PM is equal to, then what we get here, PM is equal to PM, you keep it there only, PQ take to left side, what it happens, PQ into cos theta. So what I need to find out here, I need to find out AB because projection of PQ on line L is AB. So I need to find out what is the value of AB. So PM is nothing but we know AB, correct? PM and AB are both are same. PM and AB are same. So AB is equal to PQ into cos theta. AB is equal to PQ into cos theta. So finally I got here AB is equal to PQ into cos theta. Correct? Since AB is equal to PQ into cos theta, so my value here AB, I want to know the value of AB, correct? So AB is equal to magnitude of A, because PQ is nothing but magnitude of A only. This is the vector A. So vector A is nothing but magnitude of A. Okay. So magnitude, the length of vector A is magnitude of A, correct? The length of PQ or the length of vector A is magnitude of A. So PQ is nothing but magnitude of A into cos theta. So finally I got AB is equal to, I want to know the value of AB. So because AB is a projection of vector A on line L. Okay. So I got AB is equal to PQ into cos theta. Since PQ is nothing but magnitude of vector A. So I got AB is equal to magnitude of A into cos theta. Magnitude of A into cos theta. That is the projection of vector A. That is the projection of vector A on line L is magnitude of A into cos theta. Magnitude of A into cos theta. Okay, and but here we are going to solve some problems based on one formula. That formula let us find out now. Okay, the projection of vector A on B or projection of vector A on C or projection of vector B on A, whatever they ask, they will be given the two vectors and they will ask the projection of vector B on A or on B, projection of vector, the projection of vector B on vector A, or they can ask here projection of vector A on vector B. Okay, so let me come back once again for this slide. See dear students, what I got here, projection of vector A on line L is magnitude of A into cos theta. Again I am telling, projection of vector A on line L is magnitude of A into cos theta. Okay, so now please let me write here, we know that point to remember, A dot B, we know that A dot vector B is equal to magnitude of A into magnitude of B into cos theta. This is the formula what we are studying, correct? Vector A dot vector B is equal to magnitude of A into magnitude of B cos theta. Okay, in the previous slide I said you one thing, remember point. What's that point? I asked you to remember projection of vector A on line L. Projection of vector A on line L is magnitude of A into cos theta, correct? Into cos theta. That means what we can call this one, projection of A on L is magnitude of A into cos theta. Then magnitude of B cos theta is nothing but what I can take, projection of B on line OA, correct? Or on vector A, correct? So let me write here, vector A dot vector B is equal to magnitude of A, same, magnitude of A into, this is B cos theta, magnitude of B into cos theta is nothing but projection of B on vector A, projection of B on A, I mean impact of vector B on A, it's impact on A is this much, correct? This much interpolation. Okay, so now that is magnitude of B into cos theta. Okay, now I need to find out the projection of B on A. They will ask you people to find out the question is will be like this: find projection of B on A or find projection of A on B, whatever the question may be. Okay, how to find out that? By with the help of this formula only we can find out. So then I want here projection of B on A. I want projection of B on A. This I need. That means A dot B, you keep it there itself. And this magnitude of A goes to left side. So when it goes to left side, this is my formula. Please keep in mind, this is the formula. So projection of B on A. B on A is equal to vector A dot vector B. On which it is on A. On A, so in the denominator place, magnitude of vector A will come. So you can also write it as a unit vector of A into vector B. Unit vector of A dot vector B, because vector A divided by magnitude of vector is nothing but unit vector, correct? Dot vector B. So then what will be projection of, I'm asking this one, I'm expecting the answer for this from you people. Projection of vector A on B. What will be the projection of vector A on B? On vector B. Simple. Vector A dot vector B divided by, it is on B, therefore magnitude of B. This is the point. So projection of vector A on B is nothing but A dot B divided by magnitude of B. That's nothing but equal to, you can write it as a unit vector of B, because vector B divided by magnitude of B is nothing but unit vector dot vector A.